Hey, Adele. How you doing? Oh, I like your hair. It's very blue today. Nice. And let's see, we have somebody else. Ben, where are you, Ben?
Hold on. Hello? Can you hear me? Sorry,
Yes.
hold on.
Oh, there
Oh.
you are, Ben. Hi, Ben.
Hi.
Okay, so Ben and Adele both took the AI training your computer course. So we got a knowledgeable audience.
Excellent.
And so I'm going to introduce Misha Daniil to you all. He's a AI researcher and he works at DeepMind, and he's in London where it is evening, right?
Yeah, it's 8 p.m. here, so
Wait,
a little bit.
Oh.
And Ben and Adele, what time is it in Alaska?
11:09 actually.
Wow.
Okay.
And Austin, you're in, where are you?
Same time zone as you. It's 4 o'clock here.
Oh, okay, yeah.
Excellent.
Another part of Nova Scotia. So, yeah. So we've got all the times figured out. Okay, so Misha, you've been working at DeepMind for 10 years or longer?
Almost 10 years, I think.
Almost 10 years. And
Counting.
so your work is focused on artificial intelligence research.
Yeah.
And he's done stuff with image recognition, natural language processing, and simulated agents for video games. So I think we did a couple of those types of things, certainly the simulated agents for video game. And do we do any image recognition? So, no. And natural language, I think that our text inputs would qualify as that when we did the very first project with the smart classroom. Okay, and currently Misha's working in robotics. And Ben, you're a robotics fan, eh?
I mean, I'm in a robotics program.
Excellent.
Okay.
Yeah.
And
yeah.
Yeah, we might see your whole team here.
Oh, about that. My team, I don't know if they might come because they're kind of busy. Like one teammate is currently working on something on the robot and programming. Yeah. So I don't know if they're gonna come.
So what do you
They
guys
don't.
do when you're in the robot program? Like, do you do competitions or like what do you do?
Yeah, it's this competition called First. It's pretty much for inspiration and recognition of science and technology. And I've been at it for about like 4.5 years.
Oh, awesome.
And I have a team going. And what else? I have a good friend named Jaden who acts as the driver, but he also learns about building and programming. I'm mainly the head engineer or builder of the robot.
Awesome.
Yeah.
And so you guys, like, I got into robots when I was way too old for First, so like I don't know much about it. But like, what do you guys like build a robot for like a competition that runs like periodically, or how does it work?
So the competition is set up for a specific amount, a specific task. Like let's say, we had to pick up for last year, we had to pick up blocks and balls to put on top of a hub, pretty much a tower, to score points. And then there's also other elements such as turning a carousel to drop a duck into the field.
I got you.
Yeah.
Got you. So like there'll be a different task like each year, or a different like thing you have to do each year. You guys actually build the robot for it too?
Yeah, different themed each year.
Oh, awesome.
Yeah.
That's way more technical than me. I just do the software part for robots. So like,
Cool.
it's but like that's very cool. Like
Yeah.
I've been trying for years to get like closer to actually building robots, and somehow it's like very hard to actually do. So
Yeah.
I'm sure, as I'm sure you're familiar with.
Yeah.
But
And since we are such a small group, let's introduce Abiel. What do you like to do? Or what even prompted you to take the AI course?
I like doing coding and software stuff.
okay, what kind of coding and software stuff have you done?
Like I done HTML, CSS, and JavaScript, and I made like just like samples of websites.
Awesome.
And like my dad helps me sometimes.
Yeah, that's excellent. JavaScript is a great place to learn coding. I first learned to program like way back in the day, and what was basically the same thing as JavaScript. The web was a lot less exciting when I was your age, but yeah, but that's a great place to start.
I started with Scratch, and then I moved to Python, and then I moved to HTML, CSS, and JavaScript.
Oh, excellent. Yeah.
So you did some Python too, eh?
Yeah, I mean, that's Python right now is like the sort of dominant language for that AI researchers use. Like there's a lot of it's like a very nice language to use, and there's a lot of really good tools for like building, like for doing machine learning in Python. So it's like a really good language for things in general, but also if you're particularly interested in AI, it's a good one.
I tried it, and my experience didn't go really well because sometimes when I tried like I copied a code from another person and it didn't work for some reason.
Yeah, I think that can happen in any language.
Yeah, like sometimes I literally copied and pasted a code and it still didn't work for some reason.
Yeah, I mean that's just the reality of coding, right?
Yeah.
You do that in any language, and sometimes things just don't work, and the computers don't want to tell you why.
Yeah.
Yeah. This is one of the like one way of thinking about this is like this is actually one of the really big problems in AI is like computers take everything like way too literally. So like if you've done some programming, like if you want it to do something like very simple, you have to really like spell out like every single step in excruciating detail. And like, if it was a person, you just say like, go do it, please. And they'd know what you mean. But the computers don't know what you mean. So you have to like really spell things out for them. And that's like sort of that is sort of like at the core of one of the things that makes AI very hard is like, how do you like make it so that machines understand what people want? Because we built great things with computers, but we built it by being very pedantic. So yeah, okay. I guess what I was thinking is like, I guess we're a pretty small group, so we can do this like pretty free form. Feel free to like interrupt me at any time, or I can talk or suggest things you want to talk about. But I've got a few like I think, or yeah, actually I've got a few demos I want to show, but actually I wanted to start with a question for both of you. It's actually two questions, or for any both of you or both of the instructors too, if they want to answer. But it's what do you think AI is for? That's one question. And the other is, what is like the coolest thing you could imagine like an AI doing?
But I think what AI is for is kind of just like to simulate a human to help, kind of like the brain of a human to act like a human, to be able to do stuff a human can, but a regular robot can't.
Yeah, those are good answers. It's good answers. Those are sort of more like the what does AI do? And they're absolutely correct. Like that's what AI is trying to do. But also why do we want to build those things? Like, why do people want to build like things that do what people can do? Like there's lots of other things we could be building, but yeah, go ahead, Ben.
I believe one reason to make an AI is that it's a lot less time consuming. If you gather more and more people, then it's gonna be more time for different points of views to process certain data.
Mhm.
But if you have an AI with a thinking process of, let's say, 10 to 20 or 100 humans, then it can process the information much faster and much faster than 20 humans could.
Yeah. So like you're kind of saying like one of the things AI could be for is to kind of understand things or help explain things to people that they don't understand, or help people understand like complex ideas, or like, big ideas that would take like many people a lot of time working together. Maybe we can have a machine that kind of like does something and like condenses it down and summarizes it for people somehow.
Yeah.
Is that kind of what
Yeah.
you're? Yeah. That's a great answer. That's a great answer. I think that's like one of that'll come out in a couple of the places in the demos I want to show you. But what about cool things? Like what's the coolest thing you could imagine an AI doing, or like you would want to see an AI do?
I think I would like to see an AI. It's probably a rather simple question, but an AI showing the process of how something works, like how does this complex chemical reaction works, or how does, for example, how does a black hole form?
Mm-hmm.
Because I remember looking at a video of applied mathematics, and there's this one person that researches with AI, and he says this computer, in a sense, processes how do stars react in like on the core and on the surface. But I think it'd be interesting if an AI processed on how a black hole is formed.
Yeah, that would be amazing. That's a really interesting answer.
Thank you.
Anyone else have thoughts on cool things AI could do?
I mean, that would be cool if they could do like whatever you wanted them to do.
Yeah.
Like no matter how hard it is, they could do it.
Yeah. Excellent. Yes. They could solve all your problems. That's I think you've hit on what my answer to like what is AI for is. Actually, it's to solve problems for people, right? Like it's to help them, it's to do things for them, right? Like, so yeah, that would be excellent if AIs could do that. Yeah. Do we get someone new joining here?
There are tech
Oh,
instructors.
hello?
Sorry, was having some issues with Zoom.
Oh, hello.
Oh,
So, yeah, I should have introduced Austin as one of our instructors, and this is Espen. He's also one of our instructors for
hello.
coming up.
And since
And
you joined,
up on the, I don't know where it is on your screen. I always think my screen is what everybody sees, but
That's fair.
yeah, but one in the black t-shirt is Misha.
Hello, nice to meet you.
yeah, excellent.
You know Austin, and then there's
Hello.
the two of the students from the Training Your Computer AI class we ran this spring in Alaska.
That's so cool.
Yeah, so we're going from Alaska to London, and in
Yeah,
terms of
all across the world.
in this, yeah.
Wow, amazing.
All right. So, yeah, go.
So
All right,
Austin, what's your idea on AI?
Oh yeah.
Cool thing it could do.
Sorry, was that for me?
Yeah.
Give me the question one more time.
What's the coolest thing you can imagine AI doing?
Uh,
you'd like to see?
well, I've always been a sucker for Star Wars, and I've always thought like the robots and the droids and stuff in those movies have been really fascinating. So seeing things like the Boston Dynamics dogs and all of those kind of robots that are being developed to kind of help almost take over tasks that might put a person in danger, but they can perform it without necessarily having that danger, like taking that dangerous element out of it. I always thought that was really cool to kind of see evolve over the last 10 or so years.
Yeah, that's a great answer. It's also one that like I know a lot of people who do robotics think about this. They call it like the dirty, dull, and dangerous work, right? Like that's where we want to put robots, is in all of those jobs like that, people are either, bored, in danger, or like, things like, cleaning up radioactive waste or something where it's both dirty and dangerous. But yeah, that's a great thing to be. Hello, maybe I can come back into focus. That's a great thing to have robots doing. There we go.
To allow robots to do boring things like deal with paperwork to exploring a volcano.
Yeah, exactly.
Yeah.
What about you, Espen? Since you've joined, I'm going to put you on the spot.
I'm not really sure. Like, I agree with the safety stuff, and honestly, when I was in school just now, we just finished our semester. We were actually discussing about how we should implement AI into reality and like in real life, and a lot of the discussion was about not having AI replace our jobs and rather having them work alongside us. So I feel like finding a way to implement that so that we don't give them complete control, because that could be worrisome and there would be times we might need to intervene. Finding a way to implement that would be really cool. I don't have a very specific idea in mind. I was talking with my dad about this, having a way for AI to kind of identify lies and stuff in the court cases and be on the more objective side, I feel could help a lot with the justice system.
Yeah, that's a very interesting answer. Like there's a lot of like a big idea in like the world of AI right now is something called value alignment, which is about like, how do we make sure that these like AI systems that we build that now are starting to have like, impact on society, right? Like we're not just building like, classifiers that tell you if it's a dog or a cat that's cool, but like what it like has no effect on anything. Like, AI is actually starting to get like built into sort of like institutions in society that have effects that make decisions about people's lives. And like, even if it's not, just like wholly handed over to the AIs, like they still are part of the system and still have influence on the outcomes. And so this question of like value alignment is like, how do we make sure that the decisions or the predictions or the suggestions that AI models make are in line with like this kind of society we want to have? Like, we don't want like the AIs to be mean or like to like be racist or something like that. And there's this question of like, well, how do you make sure they're not? Like, it's not sort of obvious like that they would be, but it's also not obvious how you would stop them from being if they turn out to be. So like, it's a big important question.
Yeah.
Go ahead.
I actually have a question about that and the justice system and certain things that AI shouldn't learn. I remember looking on the news and about crime and whatnot, especially about shootings and how one teenager bought a gun, even though he wasn't supposed to. It made me wonder, like, what if an AI system was implemented in the store to detect, let's say, a heartbeat? Because a person could lie based on their heartbeat. Would say if their heartbeat is faster than usual, then they could be up to something.
So that's like an interesting idea to think about. I think like it's also sort of falls under the idea of like, kind of like a lie detecting AI or some kind of like, deceit or lies or like something like that. And actually like the like really old school lie detectors machines that people made back in like the 50s and 60s that don't really work, but like people made them anyway and called them lie detectors. What they do is more or less like measure something like they kind of like clip them onto you, and they measure something about like your heartbeat, and it's something like electric about how your heart affects, like something electric in your body about how your heart does that. But I think the big challenge there, which nobody has like really insight into how to solve, is you can measure these like physiological changes in people, like their heartbeat, they get stressed, like something happens to your skin, like, if you've ever felt like goosebumps or like your hair kind of standing up, right? Like that's your skin is doing something. That's like your body is actually like reacting to something, like some idea in your mind, like you got scared and you got goosebumps. That's an idea that's changing something physical in your skin. So like you could think about like building sensors that detect that. Like you can't like directly look into people's minds. We can't do that, but we can detect these things that happen on their skin, on their body. But what we don't have, and what nobody has really any sort of convincing story about how to build, is how do you reliably go backwards from that? Like how do you, like, okay, I can measure these things about people, but how do I turn that into like some knowledge about internal states in their mind? And you can kind of make guesses, but the guess, like, and sometimes your guesses will be right. Like sometimes you can even build systems where your guesses will be right more often than chance. So like it's not a totally like zero information problem, but it is something that like nobody has a reliable answer to this, even if the sensors are reliable. Like even if you can know for sure, like there's no error in like measuring the person's heartbeat. Right. Which is also something you have to worry about if you're actually building a system like this. But like, let's say we ignore that source of error, but even that, going from like someone's heartbeat to like something about like the internal state of their mind, is like, there's too much missing information. Like maybe they just went for a run or something, right? Like, yeah, like their heartbeat's still elevated and they're just tired. They're not like, being deceitful, whereas somebody else might have a elevated heartbeat because they're being deceitful. And so like accounting for like those kind of unknowns in these systems is like nobody knows how you would do that, basically.
Yeah. Can I add on to that really quickly?
Yeah.
Good.
Yeah. In order for that to work well, because that on its own could help with giving kind of like a hint of like, hey, maybe we should keep an eye on this person. In order to be, I guess, more sure of the situation and not like misalign the situation, as we just said, is to have some sort of way of reading the different factors. Like body mannerisms is one thing that I've seen to be very reliable, at least for the most part. It really depends on each individual body mannerisms when they're lying and all that, but being able to take into account multiple factors and context is probably one of the most important part, would definitely be helpful in making the lie detection a lot more reliable.
Yeah, so there's sort of two things I want to add on to this. Like one is like it's often really tempting to think about like, deploying an AI system is kind of like an all or nothing thing, right? But you said like, maybe this is an indication of somebody we want to keep an eye on. I think that gets at something really good, which is there's softer ways than sort of handing over control to a machine to introduce like automation and prediction into a system. So like one that we were looking at like a few years ago is like using AI in hospitals. And so the thing people immediately think when you tell them AI in hospitals is you're going to have the AI make diagnoses. Like you're going to tell the AI what are your symptoms, and it's going to tell you what's wrong with you and what medicine you should take. And even if you could, so this is generally like a long way off for a lot of reasons. Like even if you could reliably do that, there's just like there's a lot of regulation around like what can you do in hospitals and how can you manage information, like what do you do if something goes wrong. Like there's a lot of very legitimate concerns there, but there's much like softer ways you can intervene. Like what we were looking at is using AI to prioritize information for doctors. So like an example is like one of the jobs, like a radiologist. So a radiologist is a doctor who interprets x-rays. Like, you know, there's like the x-ray machines, they take x-rays of people they take a lot of x-rays in hospitals after procedures to make sure something that goes wrong, if they think somebody has a problem that they can see on an x-ray. There's like lots and lots of reasons that x-rays get taken. And there's like a specialized form of doctor who like looks at these and like interprets what's in them, because it's like you know, it's not always obvious what's wrong with what is or isn't wrong on an x-ray. Like it's a pretty specialized skill set. So one of the things we were looking at is not like replacing the doctor making the decisions about like, okay, this person's okay, this person we should like, you know, there's something wrong here, we need to revisit this and so on, but about just like choosing like, okay, well, what order should the doctor look at the x-rays? Like they have 100 x-rays to get through, like which one should they look at first? And there you can, because there you can say like, you can build a system that predicts like, okay, there's a problem with this person, or like there's a problem in this x-ray. But you don't have to be like 100% reliable if what your system does is say, okay, please look at this right away. And like these ones that, you know, don't look worrying, maybe look at those after you look at this one. Don't like not look at them at all, but like look at the ones that are probably problematic first. And so and you'll increase the likelihood that like somebody with a problem will be seen more quickly. And so like that's like a kind of softer way you can think about like putting AI into these systems in ways that maybe doesn't like sort of give up control of the system or give up control of like the human part of the system just like to a machine, and sort of so we're not like at its mercy. And I don't remember what the second thing I was going to say, but I think that one's a good one.
Okay. Yeah.
So
You have some demos you were going to share.
Yeah, I have a couple demos of like, these are, I guess, just like things that are kind of happening in the world of AI and AI research that I think are pretty cool right now. So I will try to share my screen, and hopefully this will work. Can you see it?
Yeah.
Okay. So does anybody know what OpenAI is? Like, you know them, Ben?
I think I heard of these. I've seen a couple of videos. Is it the AI that if you type in an image, it will create it?
Yeah, so that's what I'm going to show. Yes. But so OpenAI is a company. They're like an AI company in the same way like DeepMind is an AI company. So they kind of like do similar stuff to what we do. But they have, you know, there's just more than one of them. There's just more than one of us in the world. But the particularly cool thing they've made recently is this thing where you can do text to image. So I don't have access to like the model itself, so we can't type in arbitrary things. But what we can look at is a few of these examples. Like, so these are like these are images generated by the model. So these come from nothing except a text description of what's in the image to an output of like this image. And so what they're showing off here is like, this is an astronaut playing basketball with cats in space as a children's book illustration.
Cool.
And so you can change these things, like you can change it to like watercolor. And so now it's like a watercolor painting, but it's still kind of the same thing going on. And they have like a few, you know, it doesn't always generate the same thing. It can come up with a few versions of these. It seems to really like, where did it go? Like replacing the planets with sort of these basketballs. But we can also change them to, we can't do teddy bears playing basketball with cats in space, but we can, so they've got this demo where you can look around with it at these. So basically, if you have access to the system, you can like type in whatever you want, and it'll generate you images. And like I said, I don't have access to this, but what I do have is their Instagram, where they've been posting like different things generated by this model. So if you click on them, they tell you what it is. Like, this is a turkey sandwich as a superhero. And this is really impressive, right? Because it's like, I mean, first of all, the image is just like well done, but like it's actually what I think is really impressive about these is the ones where it puts together concepts in ways that like probably haven't been put together like in that particular way anywhere on the internet before. Like, you know, so that to train this, they collect like this huge data set of like images and text from the internet. And they build this model that kind of like, okay, it has examples of images and text that go with it. And then they train the model to synthesize the images. But there's probably no turkey sandwich superheroes in that data set. Like, there's turkey sandwiches, there's probably turkeys. And so it has to recognize that, you know, turkeys and turkey sandwiches are different things. Like, if you draw them, they look quite different. But then it's also combined this with this concept of superhero in a way that like kind of makes sense to a person. Like, if I was gonna make a turkey sandwich superhero, I'd probably make like a sandwich with arms and legs, right? And I think that's really impressive. It's done this, like, it's kind of like combine these concepts, which is something we tend to think of as a very like cognitive process to like, you know, combine these two kind of abstract concepts in ways that like maybe don't fit together. Like, what's another good one? It's like, what is this? So this is just a pink balloon. I like this guy. So he's a soft hairy monster with sharp teeth.
Like a dust bunny.
Yeah. And they've come up with, they put quite a lot of these on here, like an infinite library. Like,
Wow.
Whoa. Oh, interesting. That reminded me of something.
they've got you know, an origami elephant. So like, and I don't know how many of these they have. It seems to keep going for a while.
And
Like,
this is a website. Oh, a Yeti. Is that a Yeti?
this is a white fur monster in a purple room.
Oh, it's a Yeti.
Wow.
I thought it was a Yeti.
It might be.
And this is a website, right? I can just type in the link and I can do this, right?
Yeah. So like, this is their Instagram. So they've been generating things and posting them on Instagram. I think you can like go to the website and they have a wait list for actually getting access to be able to type your own things in.
Right.
So you can like join their wait list. I don't know how long it is. I joined it a couple days ago and I'm not in yet. So it's at least a couple days long, but I don't know how much longer it is. But
Can I open like that OpenAI website, like what you did?
This one? Yeah, this one you can do. It's like openai.com.
Okay, cool.
So I'll send some links, or like I'll make sure you guys get links to like the things I'm showing off at the end. So like, don't worry too much about like saving them while we're talking. I'll make sure you can all get links to these things. And so this one's fun. I think this is like a fun idea. Like, this image generation is, I think it's fun. It's cool. It's very compelling to look at. And there's some like really interesting sort of like cognitive stuff going on in that it's like combining concepts that it's probably never seen before in those combinations. Like, it's probably not going to come up with, you know, if you give it like a nonsense word, it's probably not going to like know what to do with that word. I don't know, actually. That would be an interesting thing to test. Like, can you give it nonsense words and will it try to like make something out of them? I don't know. That would be a cool thing to do if we had access to the system. But it can take concepts it knows and concepts it's seen and combine them in like very sensible ways. And that's really like something that's only been possible at all in the last couple years. Like, this is not the first system that's done text image. This is a very recent one. This is it's called DALL-E 2. They had another one like a while back called Dolly. And there were a few systems that could do stuff like this before them as well. But like, it's only been sort of possible to do this combination of stuff like for a couple of years. And this is by far, I think, the most impressive version of it that's come out. So that one's fun. Another thing I wanted to show is, this is like maybe less exciting to look at if you don't know what it's looking at. Do you know what proteins are?
Yeah, I know what proteins are. Basically, what makes up one of the key components in our DNA, and that's
Exactly.
That's a protein strand, right? Or a model.
Yeah. So proteins are like the building blocks of life, right?
Yeah.
They're like bigger than atoms and smaller than cells. So like, proteins are made of atoms, like atoms are made of stuff. I don't know physics, but like, cells are made of proteins. Like all the machinery in cells is sort of built on proteins. So proteins are basically the machinery of life.
Yeah.
And they're built from these like long strands of what are called amino acids, which are themselves like molecules that kind of like form together into these long chains.
Yeah.
But in addition to being in a chain, the chains actually are like, a chain is a one-dimensional structure. It's kind of like a string, right? But what happens is when they form into the chain, they also fold. So like, if you take a piece of string and you throw it on a table, it doesn't, like, it kind of like folds up all over itself. And so proteins do this in 3D, and they do it in very particular ways that depend on the particular sequence of amino acids that make them up. And so one of the like really important problems in biology, or questions in biology, maybe problem is not quite the right word for it, but one of the really important questions in biology is, how do you, if you know the sequence of amino acids, how do you figure out what is the 3D structure of the protein that is comprised of that amino acid sequence? And this is an important problem because the sequence of amino acids is something that they can measure. Like, these are really small, so you don't just like look at them under a microscope and like count them. There's like, they do biology to figure it out. So it's quite easy to measure. It's relatively easy to figure out like these chains. So like this, like what are the letters in this sequence basically?
Right.
In what order they're in. But it's very, very hard to measure what is a 3D structure. So this is something that recently people have been trying to apply AI to do, is because there have been some of these things that have been measured. Like, it's an important enough question, because what do proteins do is really a function of what is their 3D structure. So how do they interact with other proteins? Like, how does life work is really a question of like, in some sense, a question of like, what is the 3D structure of proteins and what do they do when you put them close to each other?
Yeah, this is like one of the jobs that I would want, is like utilizing, in a sense, AI and almost animation to solve problems like this. And I do know that the CDC, I think, uses computer systems just like this to understand certain illnesses, diseases, viruses.
Yeah. It's like, it's super important to understand, illnesses and diseases, like viruses, right? Like, exactly like you're saying, like viruses are kind of like really big proteins, if you sort of. I mean, they're like a little bit bigger than that, but like they're sort of that scale.
Similar.
Yeah. And so like figuring out like what shape are they? The way viruses get into cells is by, they have like some protein on their surface, and your cell has some protein on its surface. And the virus shows up and is like, they interlink, and then your cell's like, oh, I should eat that thing. And it really shouldn't. But like, figuring out like what is the mechanism so you can make like a vaccine or something for a virus, that's really a question of, at the core of it is this question of like, what is the 3D structure of the proteins that make up the virus? And so like, this is, I don't know how to read these diagrams. Like, I don't know, the colors are something about confidence of these predictions for this thing. I'm not sure like what exactly makes these things, like why are some parts flat and some parts skinny. I don't know, but like there's now this huge database of, so this is a project DeepMind worked on. They made this huge database of protein structure predictions, they're called. So that's like the 3D structure of proteins. And this has been, I'm told, like immensely useful to biologists who want to study things like the mechanisms of diseases, or like how does stuff work in cells, is to be able to, they identify these proteins, they can do some experiments to figure out like what are the amino acid sequences that comprise them. And that's relatively easy for a biology lab to do. Like I can't do it in my living room, but if you have a molecular biology lab, you can apparently. But now they can use software to go from that, which is relatively easy, to get to this 3D structure, which if you want to like measure one of these 3D structures, this is like, a person can spend like a couple years basically working, just figuring out the structure of like one protein through measurement. But now like computationally, now the models are getting very good. We can actually make useful inferences about, or like make useful conclusions about like mechanisms of structures of proteins from looking at just these computational predictions. So I think that's one of the really exciting things going on.
This is almost like the animation of how space-time works. Basically, a very heavy of an object with a lot of mass, such as a sun, bends space-time around it.
Yeah.
Like the animation, but in this case, it's biology, and with how proteins operate.
Yeah, exactly. It's like making something invisible, like, the bending of space-time. Like we don't see it with our eyes, but like using like some animation, some visualization to make that like interpretable to people. And right, like you're saying, this is doing the same thing. Like these things are too small for us to like look at, but we can draw them on these screens in a way that like, somehow reflects some underlying truth about their structure. Yeah, that's exactly right. And then the third thing I wanted to talk about is this is a company from it's a company from Google, so it's like something that Google is doing. They're called everyday robots. So they're trying to make robots that can like do this kind of stuff, like wander around. Like this is their office, so it's like full of robot stuff, but like wander around and like do useful things for people in sort of people occupied spaces. So this is very different than, for example, like robots in factories. Like robots in factories work in like very controlled conditions. People generally like don't get too close to them, so they don't have to worry about like crushing people's fingers or stuff. And things are like, the location of objects is like very precisely controlled. Like a robot that's going to weld like a seam on a car, for example, like on a car body when it's being assembled, like that thing it needs to weld shows up in like exactly the same place every single time. The robot makes exactly the same motion every single time, and it just does this over and over and over again. And so that's like something robotics has gotten very good at over the years. But like doing something like this, like wandering around like an unstructured space, so like an office or a home or like a school or somewhere, like you can't rely on people to like not step in front of the robot, or like not stick a chair out in the hall or something like that. Like the robot, like if it's going to operate in those spaces where humans are kind of like just doing their thing, like it has to be able to deal with that. And that's very hard. It seems very easy to us because we just do it, but it's very, very hard. And I have, for this, like their website is not super easy. And if I can get over here, they have this one nice video here. Maybe I can just play it for you. It's only about 1.5 minutes long. So yell at me if it doesn't have sound, but yeah, go ahead.
Huh? No. I was just wondering. Nothing. I just said go ahead and play it.
Okay, yeah. Can you hear it?
It turned out that there's a huge amount of waste that's going into landfill because it's not properly sorted?
We have a experiment where we're trying to see if robots can sort trash into landfill, compost, and recycling.
It has to wander around buildings, find the trash cans, look in them, understand what's in them, and if something's in the wrong bucket, which actually humans are legitimately trying to get it into the right bucket, and they're still not doing it often enough, and that's why all of it's going into landfill. Look in those buckets, robot, and if you can, move it into the right bucket.
The sorting experiment is really pushing us to try and write an application that improves by itself, just in practice. Is that going to work? I hope so.
Our robots may or may not be sorting waste 5 years from now. What we actually care about is, can the robots learn from experience?
The way we made it, the tools and recipes we used to create this pick an object out of a bin capability, we'll be able to use that same recipe to learn a new skill.
The more we give the robots a problem and they get better at it just by trying to get better at it, that's the thing that will convince us that these robots are now ready to go solve lots of problems for people in their everyday lives.
Cool.
Yeah.
So,
Really cool.
So now I have a great question for you, which I think is like, actually, let me stop sharing because that's the end of the sharing part. So I showed 3 things, and I think there's like something very conspicuous in these 3 things. Is like, first one's like, generating basically images from arbitrary text. You tell it what you want, it makes it. Next one is like, doing something like sort of fundamental at the core of science. And third one is like, the robot's still kind of like clumsy, right? Like it's like, it's trying to pick up a cup, and it's not picking up a cup like I would just reach over. It just kind of goes like this.
Yeah.
Like, why is it like, what's going on here? Like, why is the robot part like struggling so much? It somehow seems like, in a way, like the robots are like way behind the rest of it or something. Like, what do you think's going on there?
I believe like it has to do with finding out a way to give a connection between the AI mind and the body itself. Because with humans, it just comes so naturally. I mean, we're born into this body and we've had years and years to learn how to use it well. And also we have like a massive range of mobility compared to robots, because like robots, they have the limitations of how far the gears can go, how fast they can go. And also sensors is a major limitation because I mean, the way that humans understand the input of information depends a lot on our sensors in a sense. So like our eyes, our ears, our sense of touch and all that. And robots don't have that. And though they may have some stuff that can somewhat replace that in a sense, so like visual sensors or infrared sensors and gyroscopes and all that, our understanding of it can be a little bit harder, and trying to implement it in a way that humans would function is hard too, because of course limitations. So trying to find a way to connect the AI mind and also the body and get it to work as fluently as a humans would is really hard. Yeah, that's just from what I've learned and experienced.
Like, go ahead, Ben.
Oh, so, I believe it's also instinct in order to do the task. Because let's say, that I'm gonna drink this water. That it's you instinctively and you put in thought to do it. But the reason why the AI, why the robot was kind of being slow and kind of deliberate with it, is because I believe it's the instinct and the thought put into it, and the process of it trying to grab it. For example, I need to write something, I can just grab it there and like what she said, and grab it and instinctively, it's meant to draw. But if you're a freshly built robot, and given that you are still learning to, let's say, pick up something, it's because you weren't necessarily designed to do that yet. Because we're designed just like what she said, run, pick up things, but that robot's wasn't born. It was built, but it still has time to process, to pick up and drop things.
Yeah, that's also a great answer. So I think you've both hit on you've each hit on one thing I think is like really important in this answer. And one of them is, so this connection between like mind and body. So like the way I like to think about that is there's this guy who did robotics back in like, I think the 1960s. So like he was one of the first roboticists in the world. His name's Hans Moravec. And he coined this idea called Moravec's paradox, which is that in AI, all the hard problems are easy and the easy problems are hard. And if you think about it, like that's really stayed true. Like he was very insightful, right? He thought this up in the 60s, but like that's still true today. Like if you think about like what was like a big accomplishment of AI in like the 1990s, so like long after him, but like long before us, was playing chess at a world championship level. That's something that like you really think like that's very hard for people to do, to be like a world champion chess player, right? Like chess is a very hard game to play. You really got to think. People who are really good at it are like way better than people who are not really good at it. But like that was like that humans were able to build like superhuman chess computers in the late 1990s.
I know what you're talking about.
Yeah, exactly. But so like, but now we're still struggling today with this, like, you know, I want to grasp a cup in like a simple fluid, quick motion, right? Like that's something like, as you know, if you didn't know to think about that, like you wouldn't even think about doing that as a person. You just do it. It's like the easiest thing in the world, this connection between our mind and our body. Is like, that's super easy for people. It's super hard for machines. And in converse, like these really like calculating problems, like, you know, I want to multiply big numbers together, or I want to like think ahead 10 moves in a chess game. Like computers are super good at this. Like that's kind of like their bread and that's intuitive to them in kind of the same way, like moving your body is intuitive to us. And then the other like really interesting thing I think you hit on, Ben, is like this idea of instinct, right? Like, so the way I think about this is like computers have machines in general have no idea what they're supposed to be doing. Like if you leave a person, you leave a person like alone in a room, you leave a baby alone in a room, like it doesn't just like sit there and not move. Like it goes around and like they're going to go around and do stuff. Like, you know, people get bored, they poke things, they pick things up. Like, you know, you want somebody to pick up a cup. Like a person knows what it means to pick up a cup. Like they have like some belief about like what it should be like to hold a cup. Like they know what they're trying to accomplish, like when they go to pick up the cups. And like giving that information to machines, like we kind of have some ways of doing that. Like that's what you're doing when you train a classifier, right? Like you give the machine examples of, well, this is good and this is bad. And then it kind of learns from that. But it doesn't have like a lot of experience with that. And if you want to teach it a new thing, now you kind of have to like go through this whole process again. Whereas people have this great intuitive understanding of like trying, like, you know, I want to learn to pick up a cup. Well, like I've already got the idea in my head of like, what does success look like? I'll know when I succeeded at picking up a cup. So now I can like try. And I mean, I'm a competent human being, so I'll probably succeed pretty quickly. But like in general, for even more complicated things, like I'll recognize when I'll like have a goal, I'll be able to recognize when I've succeeded. I'll be able to recognize when I've failed, and I'll be able to like use that information to improve my own approach to trying to accomplish the goal again. And like machines really don't have like this kind of knowledge in any innate way. So that, I think that's to me what I'm hearing kind of when you're saying like this instincts thing. Like the machines don't really know what they should be doing. And in their default thing, when they don't know what they should be doing, is just to not move at all, which is not very useful.
Yeah. It's almost like one thing I do like to do is like look at the science of what I'm watching, like either a movie or TV show, and about instinct versus like knowing. It reminded me of the show called Star Wars: The Clone Wars, and there's a distinct difference between a clone trooper and a droid. See, a droid has the knowledge to shoot, but the clone has an instinct to shoot because they're soldiers. One is programmed while one's born.
No.
One is born to know to be a soldier, while one just knows to be a soldier.
Yeah.
That's why clones were the superior soldier. All about instinct versus learning.
Yeah, so like one of the core questions of AI is like, how do we make droids that have the instincts to shoot? Although maybe we want them to shoot, maybe we want them to have the instincts to, I don't know, cook breakfast or something.
Yeah.
Guys, I think we should wrap up with
Yeah.
it. Anybody have any questions before we end this? You do? I do?
Can't hear you.
You're on mute, probably.
Doesn't look like they're on mute.
Maybe it's your mic.
Hello?
Yeah. Oh,
Yeah.
Okay. Have you guys, any one of you guys, like made a robot that could play video games, like a professional video game, like, I don't know, Fortnite, Rocket League, anything like that?
So there's two parts to that question. One is playing video games, and the other is robot. So nobody has yet made a robot that can play video games with any skill
like,
at all.
What I mean is like software, not like.
Yeah. But I see what your question is. But like a robot that can do it would be very impressive, because that's like this huge link between like, okay, motor control, but also accomplishing this like sort of bigger goal. But yeah, nobody's done that. Software, I can think of two good examples. One was OpenAI made an agent that played Dota. They played one of the international teams. I don't think they won, but like those guys are very good, right? Like they won a lot of games.
I heard about this.
Yeah,
I know what you're talking about.
Yeah, so OpenAI made one that played Dota, and DeepMind a few years ago made an AI that played StarCraft.
I heard like a kind of like I don't know, like business. I don't know how to like competition where people would make a AI robot for Rocket League, which is a game, and they would put that robot in like a tournament, and they would all compete. So like you coded the robot, and the robot was your competitor.
Yeah, that sounds awesome, actually. I don't know this competition, but like that sounds like an excellent like forum for creating AIs. Like I do know Rocket League, so like I think that would be a great game for AIs to play. I think they could get very good at it. But yeah, I don't know this competition, but I think it's a great idea. Whoever had that idea, +1 to them.
There's this game called Hello Neighbor, and the sequel of the game, I remember they put in a system where it processes the moves of each game that you play. For example, let's say you hide in the closet, and then the neighbor finds you in the closet. Then you restart the game. Then the neighbor will check the closet and see if you're there. Learns from its mistakes.
Yeah. So OpenAI made a thing a while ago where they trained agents that play hide and seek with each other. And this kind of game is really interesting from an AI perspective, because it's like a competitive game. So you have two learning agents, and they're both trying to learn to trick each other. And so this is sort of the same dynamic you also have in like a game like chess, right? Where like you're both trying to like kind of outmaneuver each other. And so if you have like two learning systems that are learning to play against each other, they can kind of like bootstrap themselves to getting better and better, because they start off like no good at anything, but they're both no good. So like neither side gets like absolutely crushed at the game. But then they both get a little better, and they both get a little better, and they both get a little better. And this actually works. Like you can make like superhuman chess playing bots through this process if you do it right.
Yeah. And on OpenAI, the image that you showed with the infinite library, it reminded me of this Marvel comic, and there's this villain called Ultron, created by Ant-Man, Hank Pym. And Ultron was intelligent enough to create a mansion that would span into 3 dimensions, I think.
Okay.
So like the library reminded me like how the AI was able to process the endless library. While Ultron was able to create a mansion that was able to stretch across dimensions.
Yeah.
I just thought it was like similar.
Yeah. That's an interesting analogy. Yeah.
Yeah.
Well, thank you all for coming and participating. Thank you, Misha, for
Oh yeah, my pleasure.
Thank you.
a bit of the things you do at DeepMind. And
What's the company again?
DeepMind.
DeepMind?
Yeah.
DeepMind. Okay. Okay, I was just wondering because.
And it's a part of is it Google or Alphabet these days?
Yeah, it's technically Alphabet, but it's it's a Google company. So we're not Google, but like we're the same umbrella. But so yeah, I'll make sure like I send like you guys get the links to all the like websites and videos I showed you, so you can.
Cool, thanks. I have a couple ideas and projects I have in mind.
Awesome, yeah.
Very cool.
Thank you.
Thank you so much.
Oh yeah, my pleasure. Thank you for asking interesting questions.
Oh.
Yeah.
Bye. Good day.
See you later.
All right.
Have a good day, everyone.
Bye.